In this section of notes, we're going to look at the sampling distribution for means. So we spent a lot of time looking at proportions. We looked at one proportion and then we looked at difference of proportions. So now we're switching gears and looking at means. So if we do a sampling distributions of means, you'll see these formulas that look somewhat familiar. We know that the mean of our sampling distribution is going to be equal to the mean of the population distribution. And we know that the standard deviation of our sampling distribution is going to be equal to our population standard deviation divided by the square root of our sample size. Don't forget that only works when either we are sampling with replacement or if our sample size is less than 1/10 of the population size. And both of these things are true whether or not the shape is approximately normal. So next up, we're going to look at figuring about the shape. Remember, we're usually interested in the shape, center, and variability. So there are a couple of things you could do here. First, if you know that the population distribution is approximately normal, then you also know that your sampling distribution will be approximately normal. The formulas we just did for mean and standard deviation, they're going to hold. So if the sampling distribution, if it's coming from a population that we don't know whether or not it's normal, then we can't just make that assumption. However, we do have something called the central limit theorem, which is a second rule that we have available to us. And the central limit theorem says it doesn't matter what the shape of the population distribution is, even if it's very skewed, then as long as your sample size is large, your sampling distribution for means is going to be approximately normal. So what is large? That's kind of an arbitrary word. So we'll look at some examples to see what we've got here. So here is a population distribution. And here is a sampling distribution from that population if I were taking samples of size 2. Here's one where I was taking samples of size 5, samples of size 10, and samples of size 25. And you can see as I've increased my sample size, it didn't matter that I had that crazy, almost like 3-piece looking population distribution, that the larger my sample size got, it became closer and closer to being approximately normally distributed. So here's our formal definition for our central limit theorem. As long as our sample size is large, then our sampling distribution of means will be approximately normal. And we're going to be defining large as 30 or more. So what's really important about this is that even if we have a population distribution that's skewed or some other way that it's not normal, we can still use the things we know and the probability calculations that we know how to do with the sampling distributions of means as long as our sample size was 30 or more. Make sure you take a few moments to try the questions from these sections and do those practice problems before moving on.